In this video, let us discuss how to find the present value of cash flows. The present value is the current value of a future sum of money or a stream of cash flows when a specific rate of return is given. The present value can be calculated for a lump sum paid or received after a specific period or equal payments or receipts at regular intervals and growing payments or receipts at regular intervals. The lump sum paid or received or the first case has been already discussed in the previous video. Hence, in this video, we are going to discuss how to find the present value of cash flows, both equal payments as well as unequal payments. Or we can say, we are going to study how to find the present value of equal cash flows and unequal cash flows. Now let us take the first case. When annuity is a series of equal payments or receipts that occur at evenly spaced intervals. That means we are going to discuss about equal cash flows. May it be a payment or a receipt. There is cash flow, equal cash flow at regular intervals. In this case, how can we calculate the present value? The formula to find present value of an annuity is PV is equal to A divided by I into 1 minus 1 divided by 1 plus I raised to n. In this formula, PV represents the present value, A is the value of individual payments in each compounding period, and I is the interest rate, or it is the rate at which the amount is compounded. N is the number of periods. Now let us take up a question. A person receives an annuity of rupees 5,000 for 4 years. If the rate of interest is 10%, calculate the present value of annuity. So it is clear from the question that that person is receiving 5,000 continuously for 4 years. In the first year, he is receiving 5,000. Again in the second year, 5,000. Third year, again 5,000. And the fourth year also, he is receiving 5,000. Hence, it is an annuity. In this question, it is clearly given that it is annuity. Even if it is not given, we can understand because that person is receiving 5,000 for 4 years. And the rate of interest is also given. Now, we are asked to find the present value of the annuity. So, the formula to be used is PV is equal to A divided by I into 1 minus 1 divided by 1 plus I raised to n. So, when applying the values in the question, PV is equal to 5,000 divided by 0.1, that is the interest rate. That into 1 minus 1 divided by 1 plus 0.1 raised to 4. 4 is 4 years. So the answer is 15,849. That means the present value of cash inflows is 15,849. For better understanding, I shall explain it. The person is receiving 5,000 for 4 years. That means 5,000 plus 5,000 plus 5,000 plus 5,000. That person is actually receiving 20,000. But we have already studied that the present value is not same as the future value. It is different. That is why here we are calculating the present value. So when the person receives 5,000 at the end of first year, that will be having more value. And at the end of second year, again he is receiving 5,000. It will be getting a lesser value. He will not get 5,000 worth from that. And at the end of third year, again he is getting 5,000. The value of that 5,000 is again less. And at the end of fourth year, he is getting another 5,000. The value of that 5,000 is also lesser than the previous 5,000s. So we have calculated the present value of all these 5,000s and we got it as 15,849. That means even though the person actually receives 20,000, the value of that 20,000 is only 15,849 for him. Instead of this, if he had received 20,000 now itself, the value of that is 20,000 itself because he is receiving it now. But here he is receiving it in 4 years. That means he is not getting the full value of 20,000. He is getting only 15,849 now. The same problem can be solved using the present value factor. For this purpose, we need the present value factor table. Let us see how it can be done. So, there are 4 years and the cash inflows are 5,000 for 4 years. Now, we need to find out the present value factor from the table corresponding to 10 percentage and first year, second year, third year, fourth year separately. So we have to look into the column of 10 percentage and rows for each one accordingly. For the first year, we have to look into the first row. For the second year, to the second row. Third year, to the third row, like that. But the column does not change because it is fixed, 10 percentage. So the present value factor at 10 percentage for each of these years is first year 0.9091, second year 0.8264, third year 0.7513, fourth year it is 0.6830. This factor is based on the value of 1 rupee after 1 year. For example, if we have 1 rupee today, after 1 year, the value of 1 rupee will reduce to 0.9091. And after 2 years, the same 1 rupee will have the value of only 0.8264. After the third year, the same 1 rupee will be similar to 0.7513. That means 75 paise. And at the end of fourth year, the same 1 rupee will have the value of only 0.6830. Sorry, 0.6830. This is when the diminishing rate is 10 percentage. Like that, if we go, the value of that 1 rupee is diminishing year after year. So based on this factor, we are going to find what is the value of the 5,000s received for the 4 years. Thus, we have to multiply each of these cash inflows with their corresponding present value factor to get the actual present value. So 5,000 into 0.9091 is 4,545.5. That means 5,000 received now will not be same as 5,000 at the end of first year. If we receive 5,000 at the end of first year, it is worth 4,545.5 only. Now, at the end of second year, what is the value of the 5,000 received? 5,000 into 0.8264, that is 4,132. And at the end of third year, the value of that 5,000 is 5,000 into 0.7513, that is 3,756.5. And the 5,000 received at the end of fourth year, let us find the value of that. 5,000 into 0.6830, that is 3,415. Now, the total amount is 15,849. That means the total present value of the cash inflows is 15,849. This was the same value that we had received in the previous way when we applied the formula to solve this problem. So we can use either that formula or this method to solve the same problem of annuity for many years at a fixed percentage. Now let us take up another problem. Here we are asked to find the total present value of each cash flows at the end of each year shown below. The rate is 8% per annum. Now 5 years are given and the cash inflows are 2,000, 3,000, 3,500, again 3,000, and at the end of fifth year it is 4,000. Let us compare this question with the previous one. In the previous problem, it was the same amount 5,000 for the 4 years. But here, each year, the amount of cash inflow is different. So, it is difficult to apply the formula. But it is easy for us to solve using the present value factor table. The present value factors for 8% is for the first year 0.926, second year 0.857, third year 0.794, fourth year 0.735, and fifth year 0.681. Thus, we can obtain the present value of all these figures by multiplying each cash inflow with the corresponding present value factor. So, the present value of 2,000 received after 1 year is 1,852, and the 3,000 received after 2 years is worth 2,571. 3,500 received after 3 years is worth 2,779. The present value of 3,000 received after 4 years is 2,205, and the last one, that is 4,000 received after 5 years. Its present value is 2,724. So, the total of these present value calculated is 12,131. That means the total cash inflows is 2,000 plus 3,000 plus 3,500 plus 3,000 plus 4,000. But its present worth is obtained by calculating 1852 plus 2571 plus 2779 plus the other two values also, that is 12,131. The total amount received is different, but its present value is only 12,131. The next case is where the annuity is growing or the cash flow is growing from one period to another. And the formula to find the present value of a growing annuity is almost similar to that of present value of annuity, but one element is included in this formula, that is growth rate. Thus, the formula is PV is equal to A divided by I minus G into 1 minus 1 plus G divided by 1 plus I whole raised to N. And PV represents present value, A represents the annuity payment in the first period. Then I is the interest rate, N is the number of periods, and the new element G represents the growth rate. Let us take an example. A dividend stream commencing 1 year hence at 66 rupees is expected to grow at 10% per annum for 15 years. If the discount rate is 21%, what is its present value? So it is given that a dividend stream is going to begin, that is, a cash flow is going to begin after 1 year, and the first cash flow is 66 rupees. After that, it is going to grow at 10% per annum for the next 15 years. So, after the first year, we are receiving 66 rupees. After the second year, that annuity is growing. 66 plus 10 percentage of 66 is received at the end of second year. And at the end of third year, again it is growing by 10 percentage. Like that, it is growing for 15 years at 10 percentage per annum, and the discount rate is 21 percentage, and we are asked to find the present value of the whole stream of cash flow. Thus, we can understand that it is an annuity that is growing, and the growth percentage is also given. Hence, we can apply the formula to find present value of a growing annuity. And all these values can be put into the formula. It becomes 66 divided by 0.21 minus 0.1 into 1 minus 1 plus 0.1 divided by 1 plus 0.21, the whole raised to 15. And hence, the present value of the total cash flows for the 15 years is 456.37. Now, let us move to the next case, present value of a perpetuity. Perpetuity is an annuity that occurs indefinitely. Perpetuities are not so common, but for example, in the case of irredeemable preference shares, the company is expected to pay the preference dividend perpetually, that is, for an indefinite period, unspecified period. So, the time period N is infinite. The time period is extremely large. So, mathematically, the N approaches infinity. Hence, the formula is present value is equal to A divided by I. PV represents present value, I is the interest rate, and A is the value of individual payments in each compounding period. So, when N becomes infinity, then the formula becomes more simple. Now let us take an example. An investor expects a perpetual sum of 500 rupees annually from his investment. What is the present value of this perpetuity if the interest rate is 10%? It is clearly given in the question that 500 is received annually, but it is perpetual sum. indefinitely, that sum is moving on. Thus, we can apply the formula PV is equal to A divided by I. So, by applying the values in this formula, 500 divided by 0.1, the present value of the total perpetual sum is 5,000 rupees. Now the next situation is where this perpetuity is growing. When the perpetual annuity payment grows at a fixed rate, the value is theoretically determined by making a small difference in this formula. Hence, the formula becomes PV is equal to A divided by I minus G. PV is the present value, I is the interest rate, G is the rate of growth of annuity. And this formula is the well-known Gordon growth model used for stock valuation. So that is how we find out the present value of different forms of cash flows. When the cash flows are equal, when the cash flows are unequal, when the period is perpetual, and when the annuity is growing, when the annuity is perpetual as well as growing, etc. Hope you understood the different cases of cash flows and how to find the present value in the different situations. Thank you for watching this video. For more videos, you can subscribe the channel.